Welcome to another video in the Formula SAE tutorial series created by SolidWorks. This video will cover the topic of fatigue analysis. The example part we'll be using here is an aluminum wheel hub. To make the process a little clearer, I'm going to start working from the context of the entire wheel assembly. Hiding the wheel and the brake components, we can actually see the hub, which is the part that rotates inside of the upright. As you can see, this is the rotating part right here, and the upright is what is stationary in the model. As the wheel rotates, the hub rotates with it, and almost all the force of the tire is going directly through the hub into this upright. That puts a lot of force on this part right here, specifically cyclic loading. Looking at an exploded view, we can get a little clearer picture. You can see the two bearings located here. They're right on this surface located over here. Opening up just the hub part, let's quickly take a look at the bearing surface. The bearings sit along this rear part of the hub, but they don't actually go all the way up to the fillet. So it's important here that I put a split line in order to section off just the face that contacts the bearings. This is important later because we'll be using it to constrain the hub as we're doing our fatigue analysis. We don't want to constrain any more of the part than is actually constrained by the bearings in real life. Before we move on, I'd like to point out exactly why this analysis is so important. In this case, I've decided to make this hub out of aluminum. While the hub, under the force of the wheel one time, might hold up, you got to remember that the hub is rotating around and around thousands of times, and that force and cyclic loading could cause a fatigue failure. Specifically, we need to worry about this with aluminum. So it's very important that with aluminum parts that are seeing cyclic loading, such as this, we perform a fatigue analysis. The first step in performing a fatigue analysis is to perform a standard SolidWorks static analysis. The results from this first study will then be fed into the fatigue analysis and will allow us to calculate results for cyclic loading. I've already opened up a study that is performed for the first static analysis. Let's take a look at some of the restraints and loads that I've put on the hub in order to simulate the wheel in motion. The first constraint I've placed is on the bearing surface. This is where most of the force of the hub is going through the bearings into the upright. I've also constrained the surface this thin ring on the back of the hub. In this specific design for the hub, there's a washer that rides against the bearing and the seal that prevents the hub from moving in either direction. So this also needs to be constrained. It may be different for your design. The first force I'll add is the vertical force of the static weight of the car going through the hub. I've simulated this by adding 4 bearing loads, each of equal weight, pointed in the vertical direction, going through the hub stud holes. The next 2 forces I'm going to add both come from the side load of the tire pushing in against the hub. This is going to create a force against the hub and also a moment around it. The force of the wheel pushing inwards against the hub I've represented along this whole face by one single force. The next force is slightly more complicated. It's important to remember that the wheel is reacting with the tire down on the ground. So this actually creates a force inward along the hub as well as a moment around the hub. In this case, to simulate this force, I've added a moment around the wheel center line, which I went and got back from my original model of the wheel assembly. Now the model shows all the forces and constraints I'll be using for this analysis. It should be noted that these are not all the forces and constraints that you might see or might want to analyze with this hub. The hub also may not see all of these forces and loading conditions at the same time. What I've tried to do here is take some of the major forces at play and put them together to form a worst case scenario. In your analysis, you may choose to use other forces that I have not included here or omit some of these forces. It's really up to you, and it's very dependent on your design goals with your hub. The next step is just to perform the analysis. In this case, I'm not going to do anything special with meshes, and I'm just going to click Run under the Run command. Let's take a look at a couple of the plots of results just as a sanity check. Here, looking at a stress plot, we can see most of the stress areas are highly concentrated around some of these nodes here and also the end of the fillet, which is what is expected. Looking at our factor of safety plot, we can see that this won't fail, at least as predicted by SolidWorks, has a factor of safety, a minimum of 7.7. You're welcome to decide if that's too high or too low. We can see that under this single static load, the part should not fail, according to this analysis. For more on doing a normal static analysis, I recommend looking at some of the tutorials, but now let's move on to performing the fatigue analysis portion. Go up to Study and click New Study, and now we should have some more options, one of them being fatigue analysis. The next step is just to add an event. Go up here to the fatigue menu and click Add Event, and then we have a few options. First, you need to specify a number of cycles. In this case, I'm just going to put an absurdly large amount so that we know the part will fail within that number of cycles and we can see what that number is. Next, I'm going to select what kind of loading we want to perform. In this case, we want fully reversed because the part is going to see full loading in both directions. And then we can also select the study, but in this case, there's only one study to select from, and we'd also like to keep one-to-one scaling. Now, all you need to do is select Run. Once the study is completed, we can look at some of the results. In this case, I've chosen to go down to the Results tab and look at the life plot. Here, we'll see the plot of exactly how long the part will last. 4 times 10 to the 7th cycles is quite a large number and should suffice for any Formula SAE hub. But you should really look at this number yourself and determine what you need for number of cycles. This is actually a fairly simple calculation to do. If you know a rough number of how many miles your car drives each year, and you can determine the radius of your wheel, you pretty much know how many cycles the hub will see roughly in its lifetime. That's it for today's video. In conclusion, I'd just like to remind everybody that this just serves as an overall guide to how to do fatigue analysis for Formula SAE parts. You shouldn't rely on any specific design decisions, loading situations, or final results that I've achieved here. As always, I'd like to invite any comments, questions, or suggestions to be sent to sfaulkner@solidworks.com. I'd also like to thank everybody that's written me already. Your suggestions have been extremely helpful, and hopefully you've seen some of them included in recent videos.